This is a side-side-side example. We have all three sides of the triangle. So the first step always in the side-side-side case is to use the law of cosines to find one of the angles. Now we can use law of cosines to find any one of those three angles. However, the second step we're going to use is law of sines. And since we can't use law of sines to find the largest angle, we might as well use law of cosines to find the biggest angle, which is angle C, first then. We would say that C squared is equal to A squared plus J squared minus 2 times A times J times the cosine of angle C. Now I've done quite a few of these problems already with side, 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 and then finding the angle. So I have a general idea of what I can do algebraically to get cosine of C by itself. I would be subtracting 13 squared, also subtracting 14 squared from both sides, and then I'm going to divide by the coefficient that's right in front of the cosine of C, and that's negative 2 times 13 times 14. In other words, cosine of C is C squared minus A squared minus J squared all over negative 2 times A times J. Evaluate all that, get it as a decimal, and since my decimal is coming out to a negative value, that's telling me that something might be a little bit different. Normally we don't have negative signs or cosines, but a negative cosine actually is okay, and my answer is going to come out to an obtuse angle of 148.7 degrees. For angles, if you have to round, always round to the nearest tenth. Even if it was 148.003, you're going to put 148.0 because it's a significant digit. Make sure you round angles to the nearest tenth. You can store that as angle or as C into your calculator. Since we already found the biggest angle, the order that we do the next one in doesn't really matter. We could find angle J or angle A next. I'll just go after J. So the sine of angle J over little j is equal to the sine of angle C, which I have stored in my calculator, over little c. To get j by itself, I'm going to multiply both sides by 14. So I'm going to evaluate 14 times the sine of C divided by 26. That gives me a decimal. Then I'll take the sine inverse of that, and I get angle J to come out to 16.2 degrees. Then to find angle A, I'll take 180 minus C, minus that answer that I just got. Not 16.2, but the answer that's still in the calculator, that exact answer in there, and A is going to come out to about 15.1 degrees. So there's our answer for this one. Side, side, side example, we use law of cosines, then law of sines, then we subtract from 180. A quick check tells me that biggest angle, opposite biggest side, smallest angle, opposite smallest side. So I'm pretty confident that my answer is correct then. The last one we're going to do right now is a coordinate problem. Coordinate problems are really just like side, side, sides. The only difference is instead of having all the sides be integers, they're going to be radicals. Now you might get an occasional integer in there, but generally you're going to get radical lengths for all these different sides. So our points are 6, 2, -1, 5, and 1, -3. You can plot these points if you like, but you don't have to. Most important thing is to use the distance formula to find the lengths of these three little sides. To find little m, that's the distance between E and B. So use the distance formula. This comes out to the square root of 68, and that is approximately 8.25. Now, what I want for the sides is approximate answers rounded to the nearest hundredth. Even if the last digit would end up being a 0, make sure you put it down there to show that it's a significant digit and you round it to the nearest hundredth. So m is about 8.25. E is the square root of 50, and that is about 7.07. And little b is the square root of 58, and that is approximately 7.62. Now these could all be simplified down in simplest radical form, but there's no reason to do that. It'll just take more time. There's a potential for error. I'm going to keep them like this and use these exact values rather than the rounded answers that I put down. Now this problem is exactly like the last one. We have side, 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 and we're going to use law of cosines to find an angle. Once again, I'm going to use that to find the largest angle, which is going to be angle M. So I'd have the square root of 68 squared, which will be just 68. I'm going to subtract the square root of 50 squared and subtract the square root of 58 squared from both sides, over negative 2 times the square root of 50 times the square root of 58, and that's equal to the cosine of M. I didn't show as much work on this one as far as how I set it up and then doing the algebra. I'm setting it up and doing the algebra all in one step. Here is my cosine of M. Evaluate the numerator, divide it by the entire denominator. One common mistake that people might make is to not put parentheses around this entire denominator. So it's all the numerator divided by all the denominator, then take the cosine inverse of that, and that's going to come out to about 68.2 degrees. Store that value. Maybe you want to store it as M because it is angle M. Then we could say sine of angle M over little m is equal to the sine of E, which we don't know yet, over little e. Multiply both sides by square root of 50. So root 50 times the sine of M divided by the square root of 68 is a decimal. Take the sine inverse of both sides, and you get angle E to come out to 52.8 degrees. Then take 180 minus M, minus that answer, and you get angle B to come out to 59.0 degrees.